Hi, this is Dr. Marvin Parent from Oakland Community College in the great state of Michigan. I'm dedicating this short tutorial for all the students who take nutrition, and the method also helps you get through elementary problems in chemistry, physics, biology, geology, astronomy. It is a great tool, and I'm happy to be presenting it to you. All right, the lecture starts with simple examples from everyday life, and then it moves on to nutrition. Now, you already know a dollar is equal to 4 quarters. All right, what you need to know is a gram is a measure of weight, just like ounces and pounds. In nutrition, it's valuable to know how many calories one has consumed to keep a balance between the food energy that you've consumed and the food energy that you have burned. We want numbers versus numbers. So an expedient way to determine energy in food starts with determining its weight in grams. Anybody that's gone on Weight Watchers or any other program similar to it knows the value of a scale, because this allows you to convert weight into energy. Well, energy in the nutrition sense is called kilocalories, but since we're dealing with most people in the outside world, we'll call it calories. Nothing wrong with that. But here's what you have to know. On the right, you need to know that 1 gram of CHO stands for, by the way, CHO stands for carbohydrate. 1 gram is 4 kilocalories. CHON actually is my way of abbreviating protein, because protein brings in an extra element that's not present in carbohydrate, also 4 kilocalories. And fat, believe it or not, fat is actually CHO as well. There's only 3 elements that make up your fat molecules. But it would be confusing to use CHO for both fat and carbohydrates, so I just abbreviate it fat. Instead of CHO, I abbreviate it as FAT. So now what we're going to do is take a look at a simple problem, and we'll start with what the problem asks for. More often than not, you're starting with a value and you're trying to find out what happens when you convert it to another. So here's an example. Again, this is an example out of your common experience. I have $6. All right, how many quarters will I get? Well, you set up a little ratio between the dollar and the quarter, and you find out it's a 4-to-1 ratio. But you write it algebraically so that $6 times 4 quarters equals 24, and the dollars actually go through a cancellation. So your answer winds up in quarters. Now, here's the nutrition side of it. I have a cracker. Let's assume it's all carbohydrate and it weighs 6 grams. If I eat it, how much food energy is in that particular cracker? It's done the same way. You start off with writing down not only the number, but the unit that goes with it. 6 grams of carbohydrate. The ratio is 1 gram of carbohydrate is 4 kilocalories. And obviously you get a little simple calculation that cancels out the units. So if I have $6 in my wallet and I want to change it into quarters, how many quarters will I get? Now just watch, because this is repetition again. But watch what happens. Dollar cancels out with dollar. And shame on you if you're not willing to write down the unit every time you write down a number. Because if you get unit cancellation and your answer is in the terms that you expect it to be, you set the problem up correctly. But let's go to nutrition. All right, I have a cracker that weighs 6 grams. How much food energy is in that cracker? Set it up the same way. You write down 6 grams of carbohydrate. It takes you 3 seconds to write down CHO, and then you write down the ratio. 1 gram is equal to 4 kilocalories. That's the ratio. 24 is the answer, and notice your grams of carbohydrate cancel out, and your answer is in the desired unit that you wish it to be in. Now, by the way, problems can work both ways. Take 48 quarters and change it back into dollars. Well, now you're going to invert that ratio. $1 is 4 quarters. Your quarters are going to cancel out, and you wind up with $12. All right, take 48 kilocalories and say how much food energy is that going to weigh? 1 gram of carbohydrate is the equivalent of 4 kilocalories. 48 divided by 4 is 12, and obviously you wind up with our grams of carbohydrate, which is the weight value we're looking for. So solving the problems in the 2 prior slides utilize simple algebraic practices. Watch. Quarters cancel out with quarters. Takes you half a second to do that cancellation. And clearly, kilocalories cancel out with kilocalories, and your answer is in the terms of the unit you expect it to be, grams of carbohydrate. Now, the other type of problem, which is somewhat confusing to students who haven't visited math for a long time, is percent. If there are 20 women in a nutrition class, then what percent of the class are females? Well, one always needs to know the total number of students to determine this. If the class size is 25, find the percent of women in this class. Well, you're always going to take what you have and divide it by clearly the total number, or a reference. In some cases, there'll be a reference number. Divide that out, you get the decimal, 0.8. But we're going to use this in terms of 0 to 100%, so we have to multiply it times 100 and change it to percent. We add that percent sign to show that we actually changed the value of that particular answer. So we got 80% of our class are females. Now, percent makes comparison very easy when evaluating one's nutrient or energy intake. For instance, this is why percent is used almost invariably when you're making comparisons. Suppose we find out that a particular food through nutrient analysis yields these results. 25 grams of fiber, 201 grams of carbohydrate. Now, unfortunately, raw numbers like those above do not mean much to the average person. Who knows what 25 grams of fiber looks like? All right. However, if the above fiber intake was 15% and the carbohydrate was 55%, then you know how far you are on a relative scale of 100%. Percent is a most valuable tool of comparison. We're going to find a common way to use the percent in nutrition. We're going to determine how much of a specific nutrient you ate. And of course, you can use the dietary analysis software to do this. But if you're going to do it with your own calculator, then this is what you need to do. Locate in a textbook your healthy target value. All right, this value is found in the dietary reference intake, and obviously it's based on your age, your gender, your height and weight. So let's suppose we look in the DRI table, and we're looking at vitamin C, but your intake, because you ate an orange, may have been 54 milligrams of vitamin C, and you look up the table and you find your DRI value is 75 milligrams of vitamin C. Well, obviously you didn't eat 100%, but what percent did you consume? All right, we're going to take 54 milligrams of vitamin C divided by 75 milligrams of vitamin C. We wind up with 0.72, which of course is multiplied by 100. We add that percent sign to show that we've changed the value of our division. And of course, your units always cancel out. There are no units on this on the right-hand side. That just happens to be percent, which shows we've altered the value. Now, using percent also is valuable too. If 80% of the student body are women, how many women actually attend O.C.C.? Well, again, you need to know some kind of reference number, and so now we're talking about the total number of students attending O.C.C., and let's assume it turns out to be 33,200. To use percent to find an actual number, in this case the number of women, change 80% back to its decimal form. Drop the percent sign, add the decimal in the appropriate location, and then multiply 0.8 times 33,200, and you get 26,560 women that attend O.C.C. at this particular moment in time. The bottom line of this presentation is this. When you perform mathematical calculations typically found in nutrition problems, geology problems, chemistry problems, physics problems, you can name the entire science scene. Take an extra second to write the units down with all numbers. If you properly apply this, then unit cancellation yields your numerical answer having the desired unit. So we're going to take 30 grams of carbohydrate, change it into kilocalories, which is energy, 30 grams CHO. There is a ratio of 4 kilocalories per 1 gram of CHO, and that yields 120 kilocalories of energy. And that's the conclusion. If you practice it, you'll find it so easy, it'll come second nature.